Hello, my senior threes. You're welcome to this lesson, senior threes and senior fours. Um, yes, we're still looking at probability theory, and in the previous lesson, we introduced ourselves to what probability is. And for those who have just joined, we can have a quick reminder here. We say that in case you have an event A, and you want to get its probability, we say that probability is simply chance. So in case you have an event A can be, for example, scoring a goal in a football game. It can be like picking a coin, and then maybe obtain a head. It can be like maybe in a group of 20 students. An event A can be picking a girl or picking a boy. So an event can be anything. So we say that the probability of getting that A is always equal to the number of A divided by the total, like that. So for example, in case you have to pick or to toss a coin, in case you toss a coin, remember that a coin has two sides. So that 2 is the total. It has two sides. One is the head and then the other one is the tail. So in case you have a coin, that is one coin, and it has a tail or it has a head, you can see that the probability of picking a head is simply equal to the number of heads divided by the total. That's what we said last time. And for this case, since there is one head and then there are two outcomes, a head or a tail, consider the probability of picking a head is equal to a half. That is what we say. So we still said that in case we're dealing with the probability theorem, in case you calculate a number, you try to solve a probability number and you get a probability or you get the answer, that answer should always be between 0 and 1 inclusive. In other words, the probability of any event lies between 1 and 0. It lies between 1 and 0, meaning that in case you calculate a probability number and you get negative or you get a number which is more than 1, then it means that you are wrong somewhere. So you need to cross-check your work. So that is some of the things that we looked at in the previous lesson. So in today's lesson, we're going to be looking at what we call probability trees. Remember, we said that there are very many ways of obtaining the possibility space. In other words, possible outcomes of an event. So among them, we said that we have what we call the probability tree, and then the others, like that. So what is a probability tree? A probability tree simply looks like this. It looks like that. In other words, assume that maybe you have a coin. Let me assume that I have a coin where I have this point O, and in that coin there is that coin has two sides, a head and then a tail, like that. Assuming that you place your hand in a box without seeing that, try to change the size, try to shake the box, and then afterwards you pick out that coin but with one face facing up, one end facing up. So assuming that you bring out that coin, you can either get a head on top or you can get a tail on top. So to represent that one as to represent that one on a probability tree, we simply use something like the arrows. In this case, we use the arrow. So this is one arrow showing one possible outcome, and then this is the other arrow showing the other outcome. So we shall be calling these arrows our branches. We shall be calling those ones our branches. And still connected to probability theorem, we say that in case you have two branches, like in this case, you have this case, that branch, and then you also have this branch. When you add up the probabilities of those two outcomes, the sum should always be equal to a 1. The sum should always be equal to 1. So that is what we call a probability tree diagram. That's called a probability tree diagram. I can give here another example, still on the probability tree diagram. Assuming that you have maybe a box again, and in that box maybe you have mangoes, or you have beads, or you have marbles, anything. Assuming that you're having mangoes, and maybe you have 3 ripe mangoes, and then maybe 3, or let me use 2. You have 2 maybe green mangoes. Those ones are not ripe, like that. Someone may ask that, what is the probability of picking at random one ripe mango? One ripe mango. So remember, we said that probability is equal to the number of that outcome that you want divided by the total. So for this case, our total will be equal to 3 mangoes plus 2 mangoes will be getting 5 mangoes in total. So in case I want to get the probability of picking out a ripe mango, I'll simply say that this is the same as the number of ripe mangoes divided by the total. Divided by the total. I'm writing NS. That NS means the number of the sample space. Number of the possibility space. We looked at that last time. So in this case, the ripe mangoes are 3 and the total is 5. So that is our probability. Likewise, the probability of picking a green mango will be 2 out of 5. So as a tree diagram, we can simply have this as 3 out of, let me first check something here. It is 3 out of 5. This is the probability of picking a red mango or a ripe mango. That is it. And then the probability of picking a green mango, it can simply be equal to 2 out of 5. So still from what we have said, we have said that in case you add up these two on a given, those two branches, when you add up their probabilities, you must get a sum of 1. You must get a sum of 1. So that is when we have had, we have picked the mango only once, like that. So we can continue picking mangoes. After picking the first mango, you can again pick another mango, then another mango, then another mango, and so on, depending on how many mangoes you want. So in such a case, we can simply come up with a tree which looks like this. That is the first time. This is maybe picking, if you have 3 red or 3 ripe, and then 2 green, you can have the green first, and then the red first. That is on the first picking. Then, in case you pick out the red, some remain there, some red will remain there, and then some green will remain there. Again, you can pick the second time, like that. Even on this other side, you can pick, like we're going to see examples of these. So the process can continue in case you want a given number of mangoes, as we shall be seeing in this lesson. So that is what we call a probability tree diagram. Now, when we're talking about the probability tree diagrams, there are some things that we need to consider. The things that we have to consider is that, for example, in case we have, in case we have, for example, a branch like this, then from this point also have another branch, and then from this point also have another branch, like that. When the outcome from a given path, the probability of something is got from a given path, we always multiply the probabilities. I can give an example here that, for example, in case we have we have like in the previous example, we have the probability of picking the first being red is maybe 3 out of 5, and then maybe this is picking out the red mango, and then the probability of picking the red mango on the second picking, I can have that one as R2, as maybe being 2 out of 4. I'm just giving an example which is the same as a half. In case you want to get the probability of picking 2 red mangoes, and you are seeing that those 2 red mangoes are coming from this branch along that path like that, so the probability of picking 2 red mangoes will simply be equal to 3 out of 5 times 2 out of 4, which is the same as a half, and be able to get the answer. That is what this number 1 here means. That is what it means. Likewise, number 2 says that when the required outcome is given by more than one path, then we add the probabilities resulting from each of the path, meaning that in case we have this branch here, also have this branch here, then we have this other branch here, it means that, for example, in case we have the red on the first picking, red on the second picking when the first one was red, and then yellow on the second picking when the first one was red, and then when the first picking was got yellow, for example, and then after that we have red on the second picking and then yellow on the second picking. We're going to be having examples of these, don't worry. So in case we have to get one red and one yellow, there are two options here. The first option is we can get the yellow, the red first, and then the yellow on the second picking. So the probabilities of these will be equal to probability of R1 then times the probability of yellow 2. Likewise, you can also get the yellow first and then the red on the second picking, meaning that the probabilities here will be probability of picking a yellow first times the probability of picking a red on the second picking. So once you have got those two, then our probability, the probability of picking one red and then one yellow in any order, we always add these two. That is what the second point here is saying, that when a required outcome is given by more than one path in a tree diagram, then we add the probabilities resulting from each of the paths. That is what we do. Again, we need to note one other thing, that like from what we've been discussing above there, two cases are considered, and this, we have those two cases as picking or choosing a given object and you replace it. In other words, you pick it and then you return it to the box. Or you can simply pick an item and then you don't return it without replacement. So those are the two cases that we have to consider in probability tree diagrams. Let's have an example and we see what we are talking about. So example number 1, they're saying that in a football competition, teams to play in given or in different groups are chosen by picking balls of the same dimensions out of a box at random. Given that there are 3 red balls and 5 yellow balls in the box, and that the 2 balls are picked one by one without replacement. Now there is one thing that we need to note here, this word here, without replacement. You pick one thing, one ball, and then you don't return it. So without replacement. Determine the probability that the 2 balls picked are red. That's the first part. Part B, that the 2 balls picked are yellow. And then part C, that the first is red. Now here they have specified. The first is red and the second is yellow. And then lastly, that one ball is red and then the other ball is yellow. So that is the question that we have, without replacement. So we can solve this question using a probability tree diagram. And I can draw my box here. I can say that assuming that I have my box here, I'm going to assume that the red is represented by R. So we have 3 red balls in the box and then 5 yellow in the box. So if I pick out a red ball, what is the probability of picking out a red ball? Remember, probability is equal to number divided by the total. So that probability will be equal to 3 reds divided by the total, which is 5. Like that. Again, by chance, I can pick out I can pick out a yellow ball. So for this case, I will say that the probability of picking out a yellow ball is equal to the number of yellow, which is 5, divided by the total, which is 8. Here I made a mistake, sorry. The total is 8, like that. So let's first go to the first path here on the side of R. So the question was saying that without replacement, meaning that in case I picked out a red ball, I'll be remaining with the 2. And then the yellow will remain the same, which are 5. Meaning that the probability of picking out a red on the second picking, I can call it R2, will be equal to 2 out of 7. Likewise, the probability of picking out a yellow on the second picking will be equal to 5 out of 7. You can see that when you add 2 out of 7 plus 5 out of 7 gives us 1. Then on the other hand, in case I picked out the yellow ball first, the red balls will remain unchanged. They will remain 3. Remember, without replacement. And since I picked out 1 yellow, it means that I will be remaining with the 4 yellow in that box there. Without replacement, you don't replace. What you pick, you don't replace it. So the remainder will be 4. So that means that on the second picking, my probability of picking out a red, given that the first one was yellow, will be equal to 3 out of 7. And likewise, probability of picking out the yellow on the second picking, given that the first one was yellow, will be equal to 4 out of 7, like that. Now, after doing this, the question was saying that what is the probability that 2 red balls are picked? 2 red balls are picked. Remember, you've picked 2 balls. So when you look at that diagram clearly, we can see that the 2 red balls are got when the first one was red and the second one was also red, like that. So meaning that the probability of getting 2 red balls will simply be equal to, now since we are having 2 probabilities, we say that on the same path we multiply them. So we shall have 3 out of 8 times 2 out of 7 times 2 out of 7. Of course, when you simplify this, we shall see that by 2 you get 4, by 2 you get 1, meaning that our answer will be equal to, this is 3. 3 times 1, that is 3, and then 4 times 7 you get 28, and that is our answer for part A. Likewise, in case you want to get, the second question was saying that picking 2 yellow balls, sorry. So part B, we shall again say that probability of picking 2 yellow balls will be equal to, how do we get those 2 yellow balls? We can see that when we follow this path, the first one is yellow, and then the second one is yellow. That is the path that we're talking about. So for this case, we shall say that the first probability is 5 out of 8, times the second probability is 4 out of 7. Of course, when you simplify this, by 4, 1, by 4, 2, our answer will be equal to 5 out of 2 times 7, that is 14, like that. So it will be 5 out of 14, like that. So that is our part B. That is our part B. Then the next question, I can rub off with this. The next question was saying that find the probability that the first ball is red and the second ball is yellow. Now here we have a particular order. We have a particular order. And that particular order says that the first ball must be red and the second ball must be yellow. So for the first ball being red is this, and the second ball being yellow will be this. So here, that is the only particular order that you're talking about here. So the probability of picking out the red first and the yellow on the second picking will simply be equal to probability of the red, which is 3 out of 8, times the probability of picking out the yellow, which is 5 out of 7 on the second picking, and our answer there will be equal to, can we simplify? No, 3 times 5, that is 15, and then 8 times 7, what do we get? 56, and that is our answer. The first being red and the second being yellow. Of course, here I can also ask a question. What is the probability of picking the yellow first and then red on the second picking? So if it is yellow first, then you'll pick out this yellow, and then red on the second picking will be this one here. So it will be 5 over 8 times 3 over 7, and that is what we shall have. Then the last question is saying that find the probability of picking one red and one yellow. One red and one yellow. For this case, they have not specified the order. They're saying that one red and one yellow. They have not told us that the first one is red or the second one is yellow. They have not specified that. So for this case, we have a choice. We can pick the red first and then the yellow on the second picking. At the same time, we can pick the yellow first and on the second picking we pick the red. So since we don't have the particular order here, we said that the probability of picking out the first being red, picking, in case there are two different paths, you get the probabilities of the path, and then afterwards you add them. So here we shall say that the probability of picking one red and one yellow will be equal to, if the first one is red, we shall have 3 out of 8, times the second being yellow is 5 out of 7, and then after that you add, you multiply. The second one, the first one being yellow is 5 out of 8, times the second being yellow, red is 3 out of 7. So when you simplify those, you'll find that the probability, of course, you add. When you simplify those, we shall see that 3 times 5, that is 15 out of 56, plus 15 out of 56. When you add those two, we shall find out that our answer will be equal to 15 out of 32. And that is our answer. You always simplify the final answer. You can pause, you can replay and try it again. Calculate, pause, calculate, and see whether you get that answer there. So that is number one. That is number one. Then number two. For number two, we're going to simply change. Where we had without replacement, we shall put it there with replacement. And everything remains the same, apart from something on the second picking with replacement. So for this case, we can say that we have our box. In that box, we have 3 red and then 5 yellow and 5 yellow, like that. So when you pick out the first one, the first red, the probability is 3 out of 8. If the first one was yellow, the probability will be equal to 5 out of 8. Now, when you pick, the saying that with the replacement, you pick out the first one, not the probability, and then replace. So if you pick out the first one being red, it means that the remainder will be 2, but when you replace, they will come back to 3 red. The yellows are still the same. The yellows are still the same, and so we have 5 yellow. Likewise, on this other side, we shall have 3 red, they are unchanged. When you pick out the yellow, there will be remaining 4, but when we replace, we'll come back to 5. 5 are yellow. Then you pick out on the second picking, red 2, the probability will be equal to 3 out of 8. Even here, yellow 2 will be 5 out of 8. Likewise, red on the second picking, when the first one was yellow, will be equal to, the probability will be 3 out of 8. And then yellow on the second picking will be, the probability will be 5 out of 8. So once you have that, then you can answer our questions. Probability of picking 2 reds. Look at the path. First red, second red. It is only one time. So we shall say that probability of this will be equal to, the probability of picking 2 red will be equal to 3 out of 8 times 3 out of 8, which gives us 9 out of 64 as our answer. Part B, probability of picking 2 yellow balls. 2 yellow balls, the first one must be red, the second must be red. So 2 yellow, that is the path. So we shall have 5 out of 8 times 5 out of 8, which gives us 25 out of 64. Like that, 64. Like that. And then part C, what is the probability? Please you can pause and try to replay again. Part C, find the probability of the first being red and the second being yellow. Red first, yellow second. What is that probability? It will be the same as probability of picking the first being red. I can show you the path here. The path is like this. In case you want to pick out the first being red and the second being yellow, that is the order. So first red, we have 3 out of 8. Second being yellow is 5 out of 8. And the probability here will be equal to 15 out of 64. And that is it. The order is specific. Then lastly, find the probability of picking 1 red and 1 yellow. 1 red and 1 yellow. So since we don't have the particular order, we can take this one as our first path. 1 yellow, 1 red, 1 yellow. The first can be red, the second can be yellow. Or the first can be yellow and then the second can be red, like that. So the probability of picking out these will simply be equal to, remember, say that for the different path, you add the resulting probabilities. So we shall have 3 out of 8 times 5 out of 8 plus 5 out of 8 times 3 out of 8. When you simplify that, you add and then simplify your final answer, we shall get 15 out of 32. So that is the answer for our question. That is the answer for our question. So in simple terms, we can have a quick summary here for the answers. You can try again and we see what we have. We said that for the first answer, the answer that we got here, The answer that we got for part A was 3 out of 28. For part B, the answer was 5 out of 14. The answer for part part C, we got 15 out of 56. And then lastly, for part D, we got the answer as 15 out of 28. That was part example 1. And then in example 2, the answers that we have got for part A, the answer was 9 out of 64. For part B, the answer was 25 out of 64. For part C, the answer has been 15 out of 64. And then lastly, for part D, it has been 15 out of 32. 32, sorry. 32. Like that. So those are our answers. So with those examples, we can solve all the other questions that are in the classroom. Please try them out and you hand in. Don't forget to like and share, and of course to subscribe to the channel. Otherwise, have a great day. See you next time.